Good evening, ma'am. I am Gamya Charita from 2nd CSM. Today I am here to present my video assignment and my topic is statistical learning methods in artificial intelligence. This is the outline of my presentation, which contains introduction to statistical learning method, types of statistical learning methods, supervised and unsupervised learning, challenges in statistical learning, and applications of statistical learning method. Introduction to statistical learning methods. Statistical learning methods are foundational techniques used in artificial intelligence. These methods aim to analyze and interpret the data to make predictions or decisions. They combine statistical theory with computational algorithms to extract useful patterns. This means the statistical learning methods are the foundational techniques used in artificial intelligence. This method is the foundational technique used in artificial intelligence. This method is mainly used to analyze and interpret the interpret the given data, and get the predictions from the data. They combine statistical theory with computational algorithms to extract the useful patterns. On moving to the next slide. Types of statistical learning methods. Statistical learning methods are mainly classified into two types: supervised and unsupervised learning. Supervised learning involves training models on labeled data to make predictions, whereas unsupervised learning focuses on the finding hidden structures in data without labels. Here we can observe the classification: supervised and unsupervised learning. Supervised learning contains regression and classification, whereas unsupervised learning contains clustering, anomaly detection, and dimension reduction. On moving to the next slide. Supervised learning. In supervised learning, the model learns from a training set which contains input-output pairs. Common algorithms include linear regression, decision trees, and support vector machines. This means the supervised learning mainly contains input-output pairs. The commonly used algorithms in supervised learning are regression technique, linear regression, decision trees, and support vector machines. The performance of these supervised learning can be evaluated by using accuracy and F1 score metrics. On moving to the next slide. Regression techniques. Regression techniques are used for predicting continuous outcomes based on the input variables. Linear regression is the simplest form, modeling a linear relationship between variables. More complex forms include polynomial regression and regularized regression methods. This means the regression techniques is mainly used for predicting the continuous outcomes. Linear regression is the simplest form in the regression techniques. On moving to the next slide. Classification techniques. Classification technique aim to categorize the data into different classes. Algorithms such as logistic regression, K nearest neighbors, and neural networks are commonly used. The algorithms which are used for classification techniques are logistic regression, K nearest neighbors, and in neural networks. The choice of classifier depends on the nature of the data and the problem at the hand. The classification of the problem can be done based on the two factors, that is the nature of the data and the problem on hand. Unsupervised learning. Unsupervised learning analyzes the data without labels responses to uncover the hidden patterns. Common techniques include clustering, dimensionality reduction, and anomaly detection. These methods are useful for exploratory data analysis and feature extraction. Unsupervised learning does not contain any labels or variables. Common techniques used in this unsupervised learning are clustering, dimensionality reduction, and anomaly detection. By using these unsupervised learning, we can explore the data and we can extract the feature extraction. The methods mainly used for these methods are mainly used for exploratory data analysis, feature extraction. On moving to the next slide. Clustering methods. Clustering methods group similar data points together based on the features. Algorithms like k-means, hierarchical clustering, and DB scan are popular choices. Clustering help in market segmentation, social network analysis, and image segmentation. Clustering is nothing but it groups the data similar data together based on the features, and algorithms used in clustering method is k-means, hierarchical clustering, DB scan are popular choices. And the clustering helps mainly in market segmentation, social network analysis, and image segmentation. Dimensionality reduction techniques. Dimensionality reduction techniques simplify datasets by reducing the number of variables. Principal component analysis is a widely used method for this purpose. This technique helps in visualizing high dimensional data and improving the model performance. Dimensionality reduction techniques are simply used for reducing the number of variables. Principal component analysis is widely used method for this purpose. These techniques help in visualizing high dimensional data, improving the model performance. On moving to the next slide. Ensemble learning. Ensemble learning combines multiple models to improve overall prediction accuracy. Techniques like bagging, boosting, and stacking are commonly used in ensemble learning methods. Random forests and gradient boosting machines are popular examples that enhance the model robustness. Evaluation metrics in statistic learning methods. Various metrics are used for evaluate the performance of statistical learning models. For classification, tasks, accuracy, precision, recall, and OCROC are commonly used. Regression tasks are often rely on metrics such as 10 mean square error and R square values. The evaluation can be done uh, in various methods in statistical learning. Some of them are classification tasks, accuracy, precision, recall, etc. On moving to the next slide. Challenges in statistical learning. Statistical learning faces challenges like overfitting and underfitting in model training, data quality, feature selection, and model interpretability are the main challenges. Addressing these challenges is essential for building a reliable and effective models in AI. This means the main challenges faced in statistical learning are overfitting and underfitting in model training. Data quality, feature selection are the most problems faced. On moving to the next slide. Applications. Applications of statistical learning. Statistical learning methods are applied across various domains, including healthcare and finance. They are used for predictive analysis, customer segmentation, and fraud detection. Their versatility makes them integral to the advancement of AI technologies. These statistical learning methods are used in various ways, mainly used in healthcare and finance, and also used for predictions. On moving to the next slide. Future trends in statistical learning. The field of statistical learning is evolving with integration of deep learning techniques. Uh, Advances in automation and interpretability are shaping the future for these methods. Ongoing research aims to refine the algorithms and enhance their applications in real world scenarios. Here we can see the simple cycle which contains the AI and machine learning trends in 2023. Generative AI. It starts with generative AI, an overlap of AI and Internet of Things, augmented intelligence, transparency, composite AI, algorithm decision making, no code tools, cognitive analytics, wearable devices, virtual assistants, data security, and natural language processing. Thank you.